All right, everyone. Sorry, I'm a few minutes late. I had a few things to take care of after my first one, but I'm here now. Hopefully, this is working well for everybody. Hopefully, you're all hearing me okay. And my plan is to go through all of this, including the 3x3 if I can. I've got exactly a half an hour. So hopefully we can get that done in a half an hour. There is an answer key for this up on Google Classroom too. If you click on this and just kind of go to the last couple of pages, that should be an answer key. And if you're kind of referring back to this later, I'd suggest maybe clicking through a little bit and checking out the work for the particular problem. And if you end up with questions still afterwards, definitely feel free to come and talk to me. Okay. So we are first going to take a look at solving each system with graphing. For each of these, all we're really doing is putting both of the graphs on the exact same coordinate plane, and then we're trying to figure out where they cross. So for number one, there's lots of different ways you could graph each of these. For our ones that we did in standard form, we usually graph them by making a table. You don't necessarily have to do that. You could try converting to slope-intercept form or something along those lines. I think I will probably graph both of these by making a table, though. So for the first one, we're just looking for numbers that just add up to 4. So 0 and 4, 2 and 2, 4 and 0 would all work. 0, 4 is right there. 2, 2 is right there. And 4, 4 is right, and 4, 0, excuse me, is right there. I'm going to connect all of those with the best line that I can. And with these, if you can extend all the way to the end of the kind of graph pretty easily, I would do it. Because you're never entirely sure where these are going to cross. Okay. For this one, this is a little bit trickier. I mean, we're kind of doing 4 times something minus 3 times something equals 9. So I'm going to start with 0 and -3. That'll put us right down there. And then I think if I make x3, that would be 12. And then if I make that 1, that'd be 12 minus 3. So that should work too. So 3 and 1 works. Oh, look. Even though it wasn't in my table for the last one, that is definitely where they cross. Okay. Now, it's not enough just to circle that point of 3 and 1. You do have to write it either as an ordered pair, or you could write it as x equals 3, y equals 1. Both of those would be acceptable ways of writing your answer. Okay. For number 2, the graphing here is a little bit more straightforward because both of these are in slope-intercept form. Okay, so for this one, my y-intercept is 3, and my slope is 1 over 1. So I'd go up 1 over 1, up 1 over 1. You can also, I'm just going to connect those with a line right now, and we're going to see if they cross at one of those points. If they don't, I'm going to need to extend my line the other direction as well. Okay. For this one, I'm going to go to -4, and then I'm going up 8 over 1. 1, 2, 3, 4, 5, 6, 7, 8 over 1. Oh, look, they crossed right there. And I didn't need to extend my line at all. And again, you could write it as an ordered pair of 1, 4, or you could write x equals 1 and y equals 4. Both of those would be acceptable answers. It doesn't really matter which. Next, we're taking a look at some substitution problems. Okay, so the first one is a very, very straightforward one, and the second one is actually really a pretty tough one. Maybe a little bit tougher than what you'd have on your test, but if you can tackle number 4, you can tackle any substitution problem. So for substitution problems, you are trying always to get x or y by itself on one side. Hey, we did that already. This one's done for us already. We already have y equals that. Okay. Now what we're going to do then is we're going to rewrite our second equation, but we're going to take out just the y. The reason we're taking out the y is because that's what was by itself on the other side of that equation. We had y equals. So we know what it's equal to, so we can take it out and replace it with what it's equal to. Everything else about our equation stays exactly the same. Now, what you'll notice, and this is a good check to see if you did it right, I am now down to one variable. I only have x's in that equation. So now after I do distributive property and combine like terms, I should be able to just simply solve for x. Okay, so after combining like distributive property and combining like terms, I end up with negative 9x minus 34 equals 11. I'm going to add the 34 over to the other side. And then I'm going to divide by negative 9. Oops. Delayed reaction. And I get x equals negative 5. Now, you don't have to take that whole process in reverse. Now what you can do is you can go to one of your original equations. I'm going to use the y equals 1. And instead of writing x, you can write negative 5 because you just solved for x and found that it was negative 5. You should get y equals 20 minus 17, or y equals 3. Now, for the second one, what you're going to do is this. Give me 1 second. Okay, so in number 4, I am going to attempt to solve for either x or y in one of my equations. Okay, and what that means for me is kind of deciding which one I want to do. I'm actually going to try to solve for this y. And the reason being, dividing by 8 is really not that bad. Anytime you divide by 8, especially if there's even numbers involved, you usually end up with a pretty nice decimal. So I'm going to add 6x to both sides. And when I divide everything by 8 over on the other side, I get negative 1 over there. And I get minus 0.75x. Now you could leave that as 3/4 if you want. I honestly think it would be, I think it would just be easier if you left it as a decimal. Okay, hang on, just give me 1 second again. All right. Now that I've solved for y, and again, I use this equation. Now I've got to use the other one. Okay. So I'm going to take out the y once again because I solved for y in the previous one, and I'm going to put in this. It's going to look a little bit weird initially, but we'll distribute. And then we'll combine like terms. So 7x minus 2.25x is going to get you 4.75x. And the interesting part here is after we add 3 to both sides, we're just going to get 4.75x equals 0. So in the end, it didn't really matter that we had a weird decimal before x because x is just equal to 0. Once you have that x is equal to 0, you can go back into any one of your original equations. And you can just solve for y. And I get y equals -1. Okay. Okay. Next page, we're dealing with elimination. Okay. So with elimination problems, you are trying to get opposites on one of your variables and then add those equations together. Okay. So what we're going to do first on number 5, you got to figure out which ones you want to get to match up and then figure out what to multiply by. If it's me, I'm multiplying by 2. The reason I'm multiplying by 2 is because when I multiply by 2, I get negative 10x, and there's a positive 10x in the other one. And that seemed to be the easiest way to get some opposites there. Okay, I'm going to add those together, and I get negative 20y equals 0. And I end up with y equals 0. So another one where we had a variable equals 0. Super fun. Okay. And then you can plug that y equals 0 into any one of your equations. It doesn't matter which one. I'm going to plug it into the second one, replace my y with 0. I end up with 10x equals 10. So I get x equals 1. For the second one, we have a couple questions now. So Jack asked, will we have a problem like number 4 with the decimals on the test? No, I mean, I really doubt that you will have one like that. Okay. Because I will probably give you stuff with whole numbers on your test. That was probably a little more challenging than we needed it to be. Okay. So we probably won't have one like that. Okay. For number 6, the thing that makes this a little bit more tricky is that we have to multiply both equations. Now, it doesn't matter which two we which variable, I'm sorry, we get to be opposites. If it's me, I don't know. I'm going to go with the x's, I guess, because I don't mind multiplying by 9 or by 4. So I'm just going to go with that one. All right. So I get 36x minus 63y equals, now this is where having a calculator will definitely help. If you can't multiply that in your head and get negative 144, so use that calculator, especially when that multiplication gets a little bit tough, because the emphasis here is not on the multiplication. The emphasis here is definitely on the process. Okay. 18 times 4 is 72. So then remember, they're not just magically canceling out, you're adding those two equations together, okay? And adding them together, we get negative 27y equals negative 216. Now, at first glance, this doesn't look like it actually matches up particularly well. You're like, oh, those are not great numbers. But if you divide by negative 27, you actually end up getting a positive 8. You do get a whole number, so y is equal to positive 8. Again, now you can go back into one of your original equations and just plug in for the y. It doesn't matter which one. I'm going to plug into the first one. And I get 4x minus 56 equals negative 16. I'm going to add that 56 to both sides, and I get 4x equals 40. I'm going to divide by 4, and I get x equals 10. So I get x equals 10, and I get y equals 8. Okay, now for the super fun and kind of a little bit lengthy problem. Okay. So Sonia asked before we move on, will any of these be a fraction? And I don't know. I feel like the answer is you're going to be dealing with a lot of whole numbers. There's a chance that I might make an x equal to a half or something like that. But there is there is probably not going to be a whole lot of fractions on there. Okay. Okay. So moving on now. Okay. So the system of equations here, I'm going to label these with some different colors so we have some references here. Luckily for me right now, this is easy. You don't at all have to color code tomorrow or Tuesday whenever you're taking this. But again, I do think it does help a little bit. Okay. I'm going to be getting rid of, I'm going to be getting rid of, yeah, I guess I'm going to go with X's. They're not perfect numbers, but I've got the positive negative mix that I like. And I really don't want to deal with that 7 with the Y's, and I don't want to deal with all negatives for the Z's. So I'm going to go with X's. First thing I'm going to do is use the first one and the second one. So I'm going to multiply the blue one. Oops, that's not blue. I'm going to multiply the blue one by -3. And I'm going to leave the green one alone. Okay. Because that's going to get me opposites on my x's. So I'm going to get -6x minus 21y plus 9z equals -9. Okay. And then follow that up with leaving the green one exactly as it is. And what I'm doing right now, even though you can't actually see me, is I'm actually doing a quick double check of my math to make sure that I did that multiplication right. Because I color coded, that was at least relatively easy for me to do. Because my hope is that I didn't really do anything wrong there, and I can, because I don't want to have to go back and check my answers. Okay, and messing up a negative sign, something like that, that would definitely be the thing that would cause a problem. So now I'm adding those equations together, and I've got -24y, I've got +7z equals 4. And now I'm going to go back and do that whole process again. So I've got to get rid of x's again. I think I'm going to go with the blue and the red. So I'm going to multiply the blue one by 5. And I'm going to multiply the red one by 2. So multiplying the blue one by 5, I get 10x plus 35y minus 15z equals 15. And then multiplying my red one by 2, I've got -10x, 12y, -10z equals -68. Once again, as I'm switching pen color here, I am, again, really quickly double checking my math. Okay, so I'm checking my multiplying by 5, and that looks okay. I'm checking my multiply by 2, and that at first glance at least looks okay. So now I'm feeling like I can go ahead and add these together. So I get 47y minus 25z equals -53. Okay, so basically, hang on a second. Okay. So now I'm going to basically put these, because I eliminated the same variable twice, now I've got to figure out how best to kind of put these two equations together. Okay. And there really is no great way to do it in this case because the numbers don't really match up. So you're basically at this point deciding kind of what you want to multiply by. Now I'm going to work my way back to the left because that's where I have room. If I were organizing this on paper, I might be able to make it look a little bit better. So I'm going to actually multiply the top equation by 7 and the bottom one by 25. Okay. Because I think that's going to give the best opportunity for us to use numbers that aren't too bad to multiply by. But in the end, I mean, I really think using a calculator here is the way to go for sure. Okay, so I get 329y, and 7 times 25 is 175. So that's minus 175z. And then 53 times 7 is 371. So it should say negative 371. And then we're multiplying by 25. So 24 times 25 is 600, but that'll be a negative 600. And then 7 times 25, we know from above, is negative 175. Oh, I'm sorry, plus 175. We're getting opposites there. And then 25 times 4 is 100. So if I add those together, I end up getting negative 271 for y. And actually, if you put those together, you also get negative 271. So I end up with y equals 1. Once you've gotten to that point, really, you're just plugging back in. Okay, so here's what we're gonna do. What we're basically going to do at this point is we're going to work our way backwards. Okay, so we just came kind of from these two equations. So we're going to use one of those two equations to help us figure out z. So I'm going to plug in for y. And I'm going to add 24 to both sides. I get 7z equals 28 and z equals 4. Once you have y and z, now you're able to go back to one of the original equations. It doesn't really matter which you use. So I'm going to go with the blue one. And all we're really doing at that point is just kind of some combining of like terms. And I'm going to add 5 to both sides now. I get 2x equals 8. And I get x equals 4. Now, the hard part in all of this is that I've shown you one method of getting to x equals 4, y equals 1, z equals 4. There are really a whole ton of different methods you could have gone here, depending on whether you eliminated x's right away, or y's right away, or z's right away. Okay. Here's hoping everybody made it back here. Sorry about that. My computer actually just kind of went silent for a little bit there, and I don't know what happened. My screen went black, but I seem to have kind of gotten everything back on. So hopefully it's back. Here's hoping anyway. So, okay. Sorry about that. We ready to go? Okay. So again, as I was saying before, I kind of got cut off a little bit. Really, I can only kind of show you one path here. There's so many different paths to go. Biggest advice here is that you just got to make sure you're checking as you go along. Okay. All right. Last but not least, we've got our graphing stuff here. I'll go a little bit over our half an hour time because I got cut off. So I want to make sure we get through this. So for these, it's kind of up to you as to what you do. If it were me, I would subtract 3x from both sides on this one, just because slope intercept form is significantly easier to deal with than not slope intercept form. Now I can use a y-intercept of -1, and I can go down 3 and over 1 as many times as I want. Okay, and I should, in this particular instance, try to fill up the graph as much as I can. Okay, the only things you're deciding now in connecting those dots are whether to use a solid line or a dashed line. If it's one of those two symbols, you're using a solid line because it's or equal to, so you want the line to count. If it's one of those two symbols, you're using a dashed line. So in this case, I am going to use a solid line. Then after that, you're just really deciding, okay, on what side do I shade? When your equation's in this format, when it's in slope-intercept form, you can actually shortcut it. So you can just say greater than or equal to is up, is above the line, less than or equal to is below the line. So that's greater than or equal to, so I can shade above the line. And your answer is that shaded region, okay? Hang on. Yeah, so Ashi's question was if it's greater than y. Yes. Okay, so because it was greater than y, you would be shading up.